All right. I'm going to do example smiley face first because I wanted to just introduce you to kind of what we've been talking about. Remember how we have the limit as x approaches 0 of the sine of x over x equals 1. And I said, okay, when we're doing this, just know that this is this limit. And then later on, I'll prove to you why this happens with L'Hopital. Ta-da! Here we are. We are using L'Hopital. So what this actually is here is I'm taking the limit as x approaches 0 of the sine of x over x. Look at what's happening. If I plug a 0 into sine of x, what do you get? 0. Good. And I plug a 0 into x, I get 0 again, right? I have this indeterminate form. This indeterminate form means I now use L'Hopital. Now here's something we didn't say previously, but this is what you need to do. I am going to write LH in front. That means I'm doing L'Hopital. So that is the reason why whenever I change what I'm taking the limit of, that's what happens. So here I have this sine of x. Whenever I go to take the derivative of sine, that's going to be cosine x, right? And I also have, let's go pink, why not? I have this x right here. When I take the derivative of x, I get 1, and that is a 1. Independent of each other, right? I've got my L'Hopital, which tells me why I've converted to cosine and 1, because I use L'Hopital. You see where I'm getting with all this? Now, whenever I go to plug 0 into cosine, that's a 1, and I've got a 1, so 1 divided by 1 is 1. Right? So now we've just proved why we use that all the time. It's just L'Hopital. Okay, but back to the same. You can just straight up use this. Anytime you see this, you know the answer is automatically 1. You don't got to go through the process of L'Hopital. We already know what that is. Okay, now let's do another example here. Here's example 1. We're going to evaluate the limit. And here is part A. I'm going to take the limit as x approaches 1 of x cubed plus x squared minus 2x over x minus 1. All right? So what do you do when you take a limit? What's your go-to method? Plug it in, right? That's what we're doing. So I've got 1 plus 1 minus 2. Oops. Over 1 minus 1. So that gives me a 0 over 0. We are learning L'Hopital. So you need to be writing your indeterminate form on your paper. So you need this piece on your paper. Write this on your paper. Because this is an indeterminate form of 0 over 0, we are now going to write LH in front. So I now have my limit as x approaches 1 with my derivative. So because I have this 0 over 0, you also need to write this LH on your paper, right? Write this on your paper. You need to write that on your paper so that I know why it changes. You can't just write crazy stuff on your paper. You actually have to work this out. Okay, so take this derivative. I've got 3x squared plus 2x minus 2 over the derivative on the bottom is just a 1. As soon as you get some number by itself on the bottom or the top for that matter, then you know there's no way to have L'Hopital again because I'm not going to have an indeterminate form. It's just a number. That's kind of cool, right? Then you plug your 1 in. So I've got 3 plus 2 minus 2 over 1. And then that'll just give me a 3. All right. So my limit up here, the limit of this limit, the value of that limit is 3. And we can use L'Hopital to get it figured out. So back when we were learning limits, we also used this and said, oh, let's factor, right? If I have this 0 in the bottom and I can't work with that, what's something we can do? Oh, we can factor. And you could still go through, factor that out, simplify and break this down and come up with your answer. That's legit. But we also have L'Hopital at our disposal, and we can do that. So either way, we could pull that off. All right, let's do one more here on this section. And then we'll make another video, because I got several more examples, so don't worry about that. So I've got my limit as x approaches 0 of 9 plus 3x minus 3 over x. Here's another situation to where when you plug in the 0, right? If I plug a 0, the square root of 9 is 3 minus 3, giving me a 0 over 0. You have to write that, showing it's an indeterminate form so that we can move forward. Now I'm going to take this derivative, so I've got L'Hopital here, and I take my limit as x approaches 0. This here is the same thing as 9 plus 3x to the 1/2 power, right? So we can just take that derivative, bring the 1/2 in front. I've got 9 minus 3x to the negative 1/2 times a negative 3 because of chain rule, right? And then whenever I take the derivative of a constant, that's 0, so I don't have anything there, over the derivative of x is 1. The same thing happens here when we go to clean this up. I'm not doing L'Hopital again. I'm just going to clean this up. So now I just straight up write the limit as x is equal to 0. And then we write this down. I've got negative 3 on top, a 2 square roots of 9 minus 3x in the denominator. All right. Oops. Oh, you're probably yelling at me, and I'm so proud of you. I just noticed that was a plus sign, and I wrote it as a minus. So then that makes that a positive too. Oh, I hope you were yelling at me. Wait. Yay, you guys are so good. I'm so thankful for you. Good, yes, that is positive. I'm going to get this off here so it doesn't look weird. Yes, that is a plus. I just happened to catch that. I'm glad I caught that. So that makes it a plus. There's no reason for that to be a minus. I just wrote the wrong thing. That's on me. Good. I bet you guys caught it, and I'm super thankful for you. All right, so let's plug this in. I've now got 3 over 2 times the square root of 9. So 3, make this 3 over 3 cancels out, and I'm left with a 1/2, right? So that's my limit. Good. Before, when we had this radical and we couldn't do this work, we would have to multiply by the conjugate. Still a valid method. But when we have L'Hopital, I think this method's a bit more efficient in order to pull that off. All right? Okay. Good job. Good job.